Here is part 2 of the 4-part series on kinematic equations involving intervals. This one's going to involve an acceleration into a constant velocity. This vehicle is starting off at an initial velocity of 5 meters per second west. The car is going to speed up with an acceleration of 2 meters per second squared west for 7 seconds. Now this car then continues with a constant velocity of 4 seconds. I like to always start with my diagram so I can kind of break this question down. In this case it's west, and I'm going to choose to make my left direction east and my right direction west. But you could do it the other way if you like. I'm going to make west positive for this question and east negative. When it comes to my diagram, I'm going to be starting at this point A, and I'm going to be moving to the west like this to a point B, and during this interval I'm going to be accelerating. I'm going to be speeding up. I'm starting at this initial velocity of 5 meters per second west, so here it is. And I'm increasing my speed to somewhat, we don't know what it is yet, we're going to have to figure that out, and then we're going to be continuing at that constant velocity for another 4 seconds. So maybe we traveled this far. So we know this velocity is going to be bigger than before, so it's going to be maybe this large, and it's at C it's going to be the exact same amount. So these vectors should be the same size. So VB and VC are going to be the same because during this interval we're at a constant velocity. My acceleration is thus 0. All right, let's write our given formally and match it up to our variables in our diagram. So where we have our initial velocity, VA, which is 5 meters per second west. And then we have our acceleration of 2 meters per second squared west. And this is happening over this time interval of A to B, 7 seconds. As for our second interval, we've got VB. It's going to be the same as VC, and it is unknown at this point. We'll have to find that. We do know, though, that our acceleration is 0, as stated before. And we know the time interval from B to C is 4 seconds. So part A is asking us what this car's total displacement is going to be. So what we're basically going to need to figure out is, what is this displacement from A to B? Let me actually clean it up a little bit. A little short. So we want to know what this displacement, once again, let's go one third time. So DAB is that length. And we're going to have to figure out what this length is as well from B to C, so that we can figure out what this total displacement is. We're also going to need to figure out what our velocity is for this interval, so let's do that first. Let's figure out what our velocity at B is. So we have everything we need to know. If we're trying to figure out what VB is, we know the initial velocity. We know the initial velocity, we know the acceleration, we know the time. Let's find an equation that is looking for the final velocity. So we have initial, acceleration, time, and final. We're looking for an equation that has final velocity in it. So it turns out it's just the typical acceleration equation, just rearranged. It's just this one here. It's V final equals my V initial plus my acceleration times time. All right, let's substitute in our values. So we've got our initial velocity, as we know, it's in the west direction. We've said west is positive, so we write that in as a positive value. Plus our acceleration is also west. And we know our time is 7 seconds. Doing that, we know 7 times 2 is 14, plus 5 is 19 meters per second. So our velocity b is going to be that in the west direction. Okay, now we want to figure out what is the displacement from A to B. So let's figure out a equation that has d displacement in it. And so we have, right now, let's look at what we're given here. We have this, and this. We're now trying to find this. So think about an equation that involves time, displacement, acceleration, and initial velocity. Now this equation is actually used quite a bit. We've got the displacement is going to equal our initial velocity times time plus 1/2 of our acceleration times our time squared. So this is for the first interval. So we'll do that. Okay, so let's put in our numbers. We've got our initial velocity, once again, is 5 meters per second. Our time is 7 seconds. And we've got 1/2. Our acceleration we know is 2 meters per second squared. And once again, we put 7 squared. Don't forget that squared. I will sometimes make that mistake as well. Just be careful to include the squared to get the correct answer. So we've got 5 times 7 is 35 meters plus, we have 7 squared, which is 49. These like 2's here are going to cancel out. So we just have 35 plus 49 meters, and that gives us 84 meters. All right, so our displacement from our interval A to B is 84 meters to the west. All right, like I said, we're trying to figure out what this total displacement is, so we need to find now what is the displacement from B to C in our second interval. Well, we know this is a constant velocity, so now that we've found the velocity at B, we know the velocity at C, it's the constant velocity, so we just use this equation. For constant velocity, it's just the average velocity is equal to the displacement over the time of that interval. And we're going to rearrange this for displacement and then substitute in our values. So we have our velocity and our time, which we know is we calculated in the first part, it's 19 meters per second. And we've got a time of, this time we have 4 seconds for this interval. So 19 times 4 is 76 meters. This is a displacement, so let's put in our information here. Okay, so we're now ready. If we're looking at the big picture here, we figured out what our displacement is from A to B. We figured out what our displacement is from B to C. So we're just going to add those two together to get the overall displacement. So my displacement from A to C is going to be the sum of my first interval, plus the sum of our second interval And we have 84 meters plus our 76 meters. That gives us a total displacement for this journey. 76 plus 84 is 160 meters. So here it is. That's our total displacement. So that answers part A. And we also, the other question was just asking, what is our final velocity? Well, we figured that out in the first section because we just end up moving at constant velocity after accelerating. That's our velocity. Let me actually just add in here that VC is going to equal this VB, right? So this is our final velocity here. Let's just sum this up in a conclusion sentence. So therefore, this is a car, I believe. Yeah, this is a car we're looking at. This car travels a total displacement of 160 meters west and reaches a final velocity of 19 meters per second west. And that's that. So that finishes up these kind of combinations of constant velocities and acceleration intervals. Next, we're going to get into reaction time, and after that, we're going to get into some meet catch type problems. I hope this helped. Thank you.